friends, welcome back to our next session on scheduling algorithms. The next issue to look at is all about priority scheduling. All the processes do not have equal priority. Some processes are more important than others, and when the important process needs to be executed, then it has to be given priority so that other low priority processes do not delay the high priority systems. So to ensure that, we make a change in the scheduling style, which we do call priority scheduling. Here each process is assigned a priority number and the CPU is allocated to the process with the highest priority. So whichever is having highest priority will get the chance first, and if more than one process has got the same priority, then either first come first serve or the shortest job or shortest remaining time, whatever things can be applied, but the priority wise it has to run. So lower the number, higher the priority in most of the cases. That means 1 means highest priority. So first priority should be given to process having priority number 1, then second priority with priority number 2, and so on. So lower the number, higher is the priority. And if two processes have same priority, then they may be scheduled using first come first serve basis. Then it is a preemptive scheduling, because when a low priority process is being served, because no other high priority process was available, therefore a low priority process was being run. On the way, if a high priority process comes up, then the low priority process is preempted and chance is given to run the high priority process. So non-preemptive, if it is, then the current process finishes even if the high priority arrives. So there may be two types of priority scheduling. One is preemptive, that is the moment a priority comes, a high priority process comes in, immediately it is stopped and given the chance. Or if it is a non-preemptive type of scheduling, then whatever current process is going on, that will be completed. Till then even the high priority process has to wait, and once the current process completes, then among all the remaining process in the ready list, whichever is having highest priority will get the chance. So two types of priority scheduling possible, but most commonly we would like to refer to preemptive type of scheduling, because when say some high priority issue comes in, then definitely we need to stop low priority activity and then continue with that. So that's what the common logic talks of. So we'll see what all various types of things are taken up in our next sessions. So let's take up an example. Here we have 5 processes, and each process has a different burst time and they have different priorities. So if it was first come first serve, then P1, P2, P3, P4, P5 will be served in this order. But if it was a shortage job first, then P2 should get the chance first, then P4 will get, then P3 will get, and then P5 will get, and finally P1 will get. Because shortage job, P2 with 1 unit, then P4 with 1 unit, then P3 with 2 units, then P5 with 5 units, and finally P1 will get the chance. So if it was a first come first serve, but we are now working with the priority. That means each process has its own priority. 1 means highest priority and 5 means lowest priority. So whichever process has a least value, that means highest priority, will be given chance first. So accordingly, P2 should be given chance first, then P5, then P1, then P3, then P4. So that's what it looks like. So first P2 should be given chance 1 unit time, and then P5 should get chance with 5 units of time, and then P1 should get a chance with 10 units of time, and then P3 should get the chance, and finally P4 will get the chance. Yeah, definitely if you try to measure the timings like waiting time, response time, or turnaround time and all that, definitely this may not be the best way, but priority matters here. So if I calculate these things, then P2 immediately starts, so nothing to wait, so it has got a waiting time 0, and the duration burst time of P2 was 1, therefore the turnaround time is 1, and it could not immediately it got the response, therefore the response time is 0. Then comes P5. P5 had to wait for 1 unit of time, because before P5 P2 was running of 1 unit time, so waiting time was 1, and turnaround time was 6. It finally completed after 6 instants, and response time, so after 1 unit of time it started executing, so the response time is 1. And after that priority 3 gets its chance, that is P1. Then P1 has to wait for 6 units of time, and it completes its job at 16th tick, and then the response, so P1 started working after 6 ticks, so response time is 6. After P1 P3 gets the chance, and waiting time was 16, and turnaround time is 18, and response time is 16. So you can see the waiting time response time is almost same in this case. And finally P4 gets in, so P4 is working for waiting for 18 units of time, and its length was 1, therefore turnaround time is 19 at a response time of 18. So on average, if you look at it, it is 8.2 unit of waiting time, 12 units of turnaround time, and 8.6 units of response time. Yeah, it looks very bad, but in reality, if you look at that, the processes here are arranged in the order of their priorities. The top priority is on the first place, and the least priority is on the last place. And if you just go through these 3 columns, we see that the top priority has minimum waiting time, top priority has minimum turnaround time, top priority has got a minimum response time. So therefore the top priority, so as the priority decreases, these times keep increasing. So 0, 1, 6, 16, 18, so you can see that they keep increasing, and definitely it should not matter, because the highest priority is getting a better response with minimum waiting time, minimum turnaround time, and minimum response time. Of course, the low priority cases may get delayed and all that, so that should not be a major issue here, because the major issue here is who has got authority, who is more important and all that. It is like in the traffic, there are different types of vehicles moving. It may be an ambulance, it may be a minister's car, it may be a common man's vehicle. Then definitely the ambulance should get the highest priority over minister's car and even the common man's car. So the highest priority is given to the ambulance, the next priority is given to the minister's car, and finally it is the common man's car. So in that case, even the common man gets delayed, doesn't make any big difference. But yes, it makes a difference. If the ambulance gets delayed, there is chance of getting loss of life. or if it can be an ambulance or it can be a fire brigade system. So make sure to allow these vehicles at their fastest way, allow them to move, so give highest priority to them so that they can save lives. So that's what is important here. Doesn't make much sense, doesn't make sense whether the low priority things are using more time or not. So the properties, the type preemptive scheduling can be preemptive or non-preemptive. The priority scheduling, the scheduling base is process priority. Starvation risk, yes, it is very high for low priority processes. So if high priority processes keep coming, then the low priority process need to wait forever. So there is risk of starvation, and fairness can be improved with aging. Now looking at the advantages and disadvantages of working with priority scheduling. So advantages is highly flexible. You can give importance to urgent and real-time processes. Like I'm moving the mouse. So when the mouse is moved, the icon mouse icon on the screen is also moving, and I would expect this motion to be in real time. As I move, it also should move it in sync with my motion of the mouse. But if it is getting delayed, definitely it is going to create a nuisance and it is going to create a big problem. I think that I am pressing here, but it was stuck somewhere else, and it gets pressed somewhere else, and that's what would happen if it is not given importance. So if you want to make it urgent activities, real-time processes, then we should give high importance to them. So we give a highest priority to that, so that the whole activity can be taken up in real time. And it supports differentiated service levels, so you can think of different levels of services, and each service can be given a different priority depending on how important that service is and all that. Like kernel level services, user level services, kernel level services will have definitely higher priority compared to the user level services. Therefore, whenever kernel level services are required, then all user level services have to wait for their turn. And definitely it is efficient for time critical applications. So whichever application is time critical, then we should be given high priority so that it works in time and all that. But the disadvantages on the other side, starvation is a big problem because low priority process may have to wait forever. If high priority processes keep coming, then this low priority process may have to wait indefinitely, and definitely there will be starvation, and that process may never get chance to run. Then the priority inversion, the low priority processes hold the resources, but they are needed by high priority one. So what happens? We look in detail about resource holding, because we don't want more than one process to use the same resource. As we were discussing, sharing the resources is a big problem. So if any process wants to use a resource which other process also may want to use, then there is something like locking mechanism. So we just lock it and say that this resource is currently useful only to this particular process, and that process which has locked a resource happened to be a low priority process, and when a new high priority process comes in, then the low priority process will be stopped and high priority process gets to work. And unfortunately, if that high priority process wanted a resource that was already locked by the previously running low priority process, then the high priority process keeps waiting for the resource to be released, and to make the resource to release, we need to run that a low priority process, which is impossible because high priority process is given chance now. Until high priority process completes its tasks, low priority process cannot come in picture. Until low priority process cannot come in picture, it cannot use the resource and release the resource. Until that releases, the high priority thing cannot continue, and therefore it will not stop. And this makes both the process to stay in that condition forever, which we call deadlock. We look into this in detail in the coming sessions, and we need to have a very good priority assignment policies. We need to say uh, among all the processes, which process should get highest priority, which process can get lowest priority. So there has to be some proper protocol for deciding this, otherwise it may create havoc. Like in the traffic, we have to have a proper guidelines of which type of vehicle should be allowed first, which type of vehicles should be allowed next, and all that. Like ambulance, fire services and all that should get highest priority. Others may wait, though, depending on the situation. So there are different situations where sometime police is important, sometime police is not important, sometime minister's car is important, sometime it may not be important. So depending on the situation, it has to be decided, and that decision has to be taken in a very fair manner, and a proper backup is required for these decisions and all that. So a proper policy is required, and creating this policy is a very tough situation. And it, if seriously, if it is not given a thought, then we may create some imbalance in providing these priorities to the processes, and that may in turn create problems to the overall system. So that's all about the priority scheduling. Hope you enjoyed this journey, and if you enjoyed it, so please do like, comment, share, and subscribe to the channel. Thank you.